In this video, we're going to take a look at section 4.3, which is an introduction to factoring. Now, our first objective, we're going to factor polynomials whose terms have a common factor. So, in the last section, in 4.2, we saw multiplication of polynomials. Okay, so we went from the left-hand side to the right-hand side. We were multiplying. Now, in this section, we're going to be starting from the right, and we're going to be writing our answers as the form on the left-hand side. This is factoring. Okay, now first we're going to take a look at the greatest common factor, the GCF. Now the GCF, this is the largest term that can divide each term evenly. Okay, so it has to be something that each term has in common. Okay, so let's take a look at our first example. It says factor out the GCF. So you're going to take a look at your two terms that we have, and you're going to see what they have in common, what common factors they have. Okay. Notice the second term. Notice our second term here, it doesn't have an x in it. Okay, so x cannot be part of our GCF. But some common factor, a common factor that they have is a 3. 3 can go into both 3 and 6. So our GCF here is 3. So let's go ahead and factor out a 3 from both of those terms. Let's see what we end up with. So if I factor out a 3 from the first term, I'm left with x squared. If I factor out a 3 from the second term, I'm left with the 2. So factoring out the GCF, I have 3 times and x squared minus 2. Now you could always double check your answers when you're factoring by multiplying it back out. So if I were to distribute this 3 back out, do I end up with the same thing that I started off with? Well, 3 times x squared, that gives me this 3x squared. 3 times negative 2 gives me this negative 6. So that indicates that we did factor it out correctly. Let's take a look at another example. Okay, factor out the GCF. Okay, so let's take a look at what they have in common. So look at the coefficients for. We have, look at the coefficients first. We have 4 and 8. Okay, a number that can go into both 4 and 8, the largest number that can go into both of them is 4. Now take a look at your x's. Okay, now you want to see how many x's do they have in common. The first term, this has 5 x's. This is x times x times x times x times x. The second term, this has 3 x's. This is x times x times x. So the most that they could have in common would be 3 of them. So x to the third power would be our part of our GCF. Now let's go ahead and factor out that GCF. So we're going to pull that out. We're going to factor it out, put it on the outside, and then we're going to write out what's left over if we factor it. So from the first term, I took out the 4 and I took out 3 of the x's. That's leaving me with x squared. Now the second term, if I factor out a 4x cubed, I'm left with 2. Remember, you can always double check by distributing. 4x cubed times x squared, that gives me the 4x to the 5th. 4x cubed times negative 2 gives me negative 8x cubed. Let's take a look at another one a little bit harder. Okay, so look at the coefficients first. We have 6, 21, and 3. So the biggest number that can go into all 3 of these is 3. 3 goes into 6, it goes into 21, and it also goes into 3. Now let's take a look at how many x's they have in common. Over here we have an x squared, an x cubed, and another x squared. So the most they have in common is x squared. Now take a look at the y's. See how many they have in common? This is a y to the first power, y to the second, and y to the third. So the most amount they have in common is just 1y. So that's all we could factor out from those 3 terms. So our GCF here is 3x squared y. Okay, now let's go ahead and factor it. So if I factor out 3x squared y from the first term, I'm left with 2. If I factor it out of the second term, so if I factor out 3 from 21, I'm left with 7. If I factor out an x squared from the x cubed, I'm left with 1x. If I factor out 1y from the y squared, I'm left with just 1y. Okay, and now the last term, okay, if I factor out 3x squared, So I'm factoring out the whole 3, the whole x squared, and now I'm pulling out 1y from y cubed, leaving me with y squared. And now we factored out the GCF. Okay, here's another example of factoring out the GCF. Now this one's a little bit different because notice how our x squared here, the coefficient's negative. Now it's always a good idea to factor out the negative with it. Okay, this is going to make it a lot easier when we see some other factoring techniques in the next section. So I'm going to go ahead and, let's take a look at what they have in common over here. So first, not all 3 terms have an x, so x cannot be part of our GCF. But now take a look at the coefficients, 3, 15, and 9. The largest number that can go into all of them is 3. But since my x squared term is negative, I'm going to take out a negative 3. I'm going to factor out the negative 3 from that. So if I factor out a negative 3, okay, so let's factor that out. I'm going to be left with x squared for the first term. Now when you're factoring out a negative, all the signs are going to change. Now if I factor out negative 3 from negative 15x, I'm left with positive 5x. Factor out a negative 3 from positive 9, I'm left with a negative 3. So it gets a little bit trickier when you're factoring out a negative with it, but remember, you could always double check by distributing this back out. Let's see if you end up with the same thing. Negative 3 times x squared, that gives me that negative 3x squared. Negative 3 times 5x gives me negative 15x, and negative 3 times negative 3 gives me that positive 9. Let's take a look at one more problem with the GCF. So factor out the GCF, we have 3x times x plus 2 minus 2 times x plus 2. So now with this particular problem, it's not just like one term that they have in common, but they have a binomial that they both have in common. Notice that they both have an x plus 2. So what we're going to do is factor out an x plus 2. Okay. So I'm going to factor out the x plus 2. Now if I factor out x plus 2 from that first term right over here, I'm left with the 3x. If I factor it out from the second term, I'm left with the minus 2. Now this process, this is going to be really important with our next factoring technique. This is going to be part of the process. You're going to have to factor out a common binomial. So this leads us to our next objective. We're going to factor polynomials with 4 terms by grouping. Now, whenever you have 4 terms in the polynomial, your first instinct when you're factoring is to factor by grouping. Now, the way that factor by grouping works, you're going to group the first 2 terms and group the last 2 terms. Then you take a look at each group and you factor out the GCF from each group. Next, you're going to factor out the common binomial, like we just saw in that previous example. Let's work this one out. So I'm going to group the first 2 terms. So I have x cubed plus 5x squared. Let me rewrite these with black. Okay, then you're going to put a plus in between your 2 groups. And then group the last 2 terms, 4x plus 20. Now take a look at each group, and you're going to factor out the GCF from each group. So from this first group right over here, we can factor out an x squared, and we're left with x plus 5. Take a look at the second group. The GCF for 4x and 20 is 4. So I'm going to factor out a 4 from there. I'm left with x plus 5. Okay. Notice we have a common binomial now. So what we're going to do is factor out that common binomial. So I'm going to put x plus 5 on the outside, and then you're going to write what's left over when you factor it out, which is x squared plus 4. And now we completely factored out this polynomial with 4 terms. Remember, whenever you want to check your answer, you could go ahead and multiply them back out. So we do that on the side over here. Take your x, distribute this out to each one of these terms. So you have x cubed plus 4x. Take the 5, distribute this out. We have plus 5x squared plus 20. And if you rearrange the terms in descending order, you have x cubed plus 5x squared plus 4x plus 20, which is exactly what we started off with in the beginning. Okay. So our answer here is x plus 5 times x squared plus 4. Let's take a look at another problem. Okay, factor by grouping. Okay, notice we have 4 terms here, so this is a key indicator that we're going to factor by grouping. So let's group the first 2 terms together, put a plus, and then group the last 2 terms together. So you have 5y cubed plus 2y squared. We have negative 10y and then minus 4. From the first group, GCF here is y squared. We have 5y plus 2. Now the second group, okay, GCF, we have a 2. So a positive 2. And if I factor out that positive 2, I'm left with negative 5y, negative 5y minus 2. But notice here, these two binomials are not the same. So instead of factoring out a positive 2, what we could do instead is factor out a negative 2. So now if we factor out a negative 2 from there, this gives us a positive 5y and a plus 2. And now we have the same binomial. We could go ahead and factor that out. So take out the 5y plus 2, put it on the outside, and what's left over is a y squared minus 2. And then we're finished. Let's take a look at one last one. So factor by grouping. Let's group the first 2 terms together, put a plus, and then group the last 2 terms. Okay, now factor out the GCF from each group. So from the first group, I notice they both have an x, so I could factor out an x, and now I'm left with y plus z. The second group, they both have a w in common, so I can factor out that w. I'm left with y plus z. So I have a common binomial here, which is y plus z. So I'm going to go ahead and factor that out. And now I'm left with x plus w. So that was it for section 4.3. If you have any questions, don't hesitate, just email me and I'll help you out.